Imagine you're standing on the deck of a starship, parked a safe distance away from the most terrifying object in the universe, a supermassive black hole. You're watching your best friend, an astronaut who has volunteered for the ultimate one-way trip, drifting toward that shimmering, dark sphere. You expect a dramatic ending. You expect to see them cross a line and vanish into the abyss, perhaps with a flash of light. But as you watch through your telescope, something deeply unsettling happens. Your friend doesn't speed up, they don't disappear. Instead, they start to slow down. They get closer and closer to the edge, the event horizon, but they never quite touch it. They just hover there, frozen like a fly in amber. Their image begins to redden, fading into a ghostly, dim silhouette. You wait an hour, a day, a century. You could wait for the last star in the universe to burn out, and you would still see your friend perfectly still, stuck on the doorstep of infinity. You've been told that light is the fastest thing in the universe, but here, time itself has been mugged. Tonight, we're going to look behind the curtain of the event horizon. We're going to find out why, from your perspective, your friend never actually falls in. We'll explore why the speed of light is actually a refresh rate for reality, why gravity is just a dent in the floor of the universe, and why the now you experience is a local hallucination. By the end of this, you'll realize that falling isn't what you think it is, and the universe is far more interested in keeping secrets than it is in letting things end. To understand why your friend gets stuck, we have to throw away everything you learned about speed in middle school. Most people think of 299,792,458 meters per second, the speed of light, as a speed limit, like a sign on a cosmic highway. But light isn't a thing that moves, it's a refresh rate. Think of the universe as a massive video game. The number c is the maximum speed at which the game can update its pixels. If something happens at point A, the quickest point B can find out about it is the speed of light. It is the speed of causality. In our universe, space and time aren't separate things. They are woven into one fabric called spacetime, and here is the tax that reality collects. Every object in the universe is moving through spacetime at a constant, combined speed, the speed of light. Right now, sitting in your chair, you are moving through time at the rate of 1 second per second, because you are sitting still. In space, you're using 100% of your speed budget to move through time toward tomorrow. But if you start moving through space, you have to borrow some of that budget. This is why, if you fly on a rocket at 99.9% the speed of light, your clock actually ticks slower. You've diverted your motion from time into space. This isn't an optical illusion. It's a physical law. Your GPS satellites have to account for this every day, or your Google Maps would be wrong by miles within 24 hours. Now take this logic to a black hole. A black hole is so massive that it warps spacetime into a well so deep that even light can't climb out. Near the edge of this well, gravity is so strong that it doesn't just pull on your body. It pulls on the budget of your time. Most people think gravity is a pull, like a giant invisible hand reaching out from the earth to grab an apple. Newton thought so too. He called it action at a distance and admitted he didn't really understand how it worked. But Einstein realized that gravity isn't a force at all. Gravity is geometry. Imagine a trampoline. If you place a bowling ball in the center, it creates a curve. If you roll a marble nearby, the marble doesn't feel a pull from the bowling ball. It just follows the curve of the fabric. When you fall toward Earth or toward a black hole, you aren't being pulled. You are following the straightest possible path through a curved space. In fact, Einstein's equivalence principle says that free fall is the most natural state in the universe. An astronaut orbiting Earth feels weightless because they are technically just floating along a curve. They aren't falling in their own mind. They are just moving in a straight line through a bent universe. But a black hole isn't just a curve, it's a puncture. As you get closer to a black hole, space and time swap roles. To you, the observer on the starship, the space near the black hole is so distorted that forward in space becomes down into the hole. But because time and space are linked, the black hole doesn't just curve the room, it curves the clock. This is why your friend slows down as they descend into the gravity. Well, their time budget is being drained by the extreme curvature. To them, 1 second still feels like 1 second. But to you, looking from the outside, their 1 second takes an hour, then a year, then 1,000 years. Now we hit the wall, the event horizon. This is the point of no return, but point is the wrong word. It's a threshold where the escape velocity required to leave is faster than light itself. Since nothing can go faster than c, nothing can come back. But here is where it gets obviously nuts, as Feynman would say. From your perspective on the ship, as your friend approaches that horizon, the refresh rate of reality for them slows down to zero. For them to actually cross the horizon, they would need to experience a moment in time that from your point of view never arrives. Think about the 8-minute light from the sun. We say it takes 8 minutes for sunlight to reach us. But the photon, the light particle, experiences exactly 0 seconds. To the photon, the sun and your eye are touching. A black hole is the reverse. At the event horizon, the time dilation becomes infinite. For you to see your friend cross the horizon, you would have to wait for an infinite amount of time to pass in your own universe. You are watching a movie that has been paused on the final frame, but it hasn't just paused. The frame is being stretched across eternity. Your friend, however, has a very different Tuesday. To the falling astronaut, nothing special happens at the horizon. They don't hit a wall. They don't see a sign that says abandon hope. They just keep drifting. Because they are in free fall, they are following the natural geometry of space. They cross the horizon in a few seconds of their time. How can both be true? How can they be frozen for you but falling for them? This is the relativity of simultaneity. There is no universal now. Your now and there now have been ripped apart by the mass of the black hole. You might ask, if they are stuck there forever, why can't I just see them indefinitely? The answer is the redshift. Light is a wave, a wiggle in the electromagnetic field. As your friend drifts toward the black hole, the light bouncing off their suit has to climb out of that massive gravity well to reach your telescope. Climbing out of gravity is hard work for a photon. It can't slow down, light always moves. At sea, so it loses energy instead. When a light wave loses energy, its wiggles get stretched out. The blue light from your friend's suit shifts to red, then to infrared, then to radio waves. Eventually, the waves are stretched so thin that they are longer than the entire starship. Your eyes can no longer detect them. Your friend doesn't just stop. They fade, they become a gravitational ghost. They are technically still there, plastered onto the event horizon in your now, but they are essentially invisible, a frozen echo of a person who in their own timeline is already long gone. This brings us to a terrifying realization about time itself. Physicists often talk about the block universe. Imagine the entire history of the universe from the Big Bang to the final whimper as a giant loaf of bread. Every moment is a slice. You are just a conscious observer moving through the slices one by one in the loaf of the universe. Your friend is at the event horizon. That slice of spacetime exists forever. Just because you aren't on that slice anymore doesn't mean the slice is gone. This means that the past isn't actually behind us. It's just located in a different part of the block. When you look at a star 4 billion light years away, you aren't looking into the past. You are looking at a slice of the universe that is simply located elsewhere in the 4D block. The same is true for your friend. At the edge of a black hole, the slices of time get crowded together. From your perspective, you are seeing the accumulation of every moment of their approach, all stacked on top of each other. They never finish falling because, in your section of the block, their finish is located at a time. That hasn't happened yet, and for a black hole, it may never happen in the lifespan of our universe. Why does any of this happen? Why are we the ones stuck in the slow lane while light and black holes get to play with the fabric of reality? The answer is mass. Mass is a fatal flaw in our freedom. Because we are made of atoms, protons, neutrons, and electrons, we have inertia. We resist change. We drag our heavy bodies through the fabric of spacetime, and that drag is what we perceive as time. If we had no mass, we would be light. We would experience no time. We would fall into the black hole instantly, but because we have mass, we are anchored to a sequence. We are forced to wait. Time is the price we pay for existence. Without mass, the universe would be a single, timeless flash. There would be no stories, no music, no first kisses, and no long-distance starship voyages. A black hole is the place where that price becomes infinite. It is a region of space that has so much mass that it essentially stops the clock for anyone watching from the outside. It is the universe's way of saying, the story ends here, but I'm going to take forever to tell you the last word. So why does falling into a black hole never finish? It's because the universe isn't a racetrack. It's a conversation. When you watch your friend freeze at the horizon, you are seeing the limit of how fast the universe can communicate. You are seeing the refresh rate of reality hit its absolute zero. Your friend is gone, but to you, they are an eternal monument. You are connected to them by a bridge of light that has been stretched to its breaking point. The next time you look up at the night sky, realize that you aren't looking at objects in space. You are looking at a field of interactions. You are looking at the update of a universe that is constantly trying to resolve itself. A black hole is just a part of the universe that has stopped updating for us. It is a null point in the geometry of existence. We are the slow-motion camera capturing the miracle of a single brilliant flash of existence. We see the 8-minute delay, the frozen astronaut, and the aging stars because we are the only ones who can appreciate the sequence. Don't be afraid of the infinite wait, because in the eyes of the light, everything is already finished. And in the eyes of the mass, the story is just getting interesting. Keep looking up, keep asking why, and remember, the most important part of the machine is the part you cannot see: the space, the fields, and the time that refuses to end.